Okay, Assalamualaikum and hi to everyone who's watching this video. Okay, so in this video, we are going to focus on Chapter 9 in KSSM Mathematics Form 4, which on the topic probability of combined events. And in this video, we're going to focus on 9.3, which is about mutually exclusive events and non-mutually exclusive events. So, today's learning standard in this video, we are going to differentiate. The first one, we are going to differentiate between mutually and non-mutually exclusive events. Alright. And second thing, we are going to verify the formula of probability of combined events for mutually exclusive and non-mutually exclusive events. So these are two learning standards that we are going to achieve in this video. Okay, so the first one, we are going to differentiate between mutually exclusive and non-mutually exclusive. So as you can see here is a Venn diagram which we have set P, Q and R. The elements of P are 2, 4, 6, 8. The element of Q, 2, 3, 7, 5. And the element of R is 5 and 15. So which of the following events or which of the following sets, okay, the sets represent the events. So which of the events are mutually exclusive and which of the events are non-mutually exclusive? Alright, so from this Venn diagram, okay, between P and Q, the relationship between P and Q, as we can see here, P is the square in the diagram and Q is the oval shape in the diagram. And we can see that P and Q have one same element, which is 2 here. 2 is element of P and 2 is also element of Q. So that means P and Q, there are intersection between P and Q. So we can conclude that P and Q is actually non-mutually exclusive event. Alright, so I think if you know that P and Q is non-mutually exclusive events, so for P and R, we can notice that P and R, there is no intersection. Okay, P is here, the square, and R is here, the triangle shape. No intersection, no same element between P and R. So we can conclude that P and R mutually exclusive events. And so the last one, R and Q. So R, the triangle, and Q, the oval, we have one same element here, which is 5, and therefore R and Q is non-mutually exclusive events. Alright. Okay, so from this example, what can we conclude is that a combined event P and Q is mutually exclusive event if there is no intersection between P and Q. Okay, or in set notation, we can write that P intersect with Q is equal to empty set. There is no intersection between P and Q. Very exclusive. It's like exclusive people, exclusive. Kita orang exclusive, so we will not be connected with other people's. Okay, duduk pun bilik special. So very exclusive. So there's no intersection. Okay, but if P and Q is non-mutually exclusive event, that means there will be intersection. There is intersection between events P and Q, or in set notation, you can say that P intersect with Q is not equal to empty set. Okay, bila P and Q does not equal to empty set, that means there is intersection. When P and intersect with Q is equal to empty set, that means there is no intersection. Okay, hopefully you understand the relation between intersection and also the set notation that I use here. Okay, so that's basic definition of mutually exclusive event and non-mutually exclusive event. Okay, so using the same examples here, we are going to verify formula of probability of mutually exclusive and non-mutually exclusive events. Okay, so here, as we can see from this example here, alright, so what can we say about the probability of P? PP. Probability of getting elements in P. As we can see here, the elements of P are 2, 4, 6 and 8. So there are 4 elements of P, and the total elements in this Venn diagram is 1, 2, 3, 4, 5, 6, 7 and 8. There are 8 elements. So the probability of getting elements of P is equal to 4 over 8. Or we can simplify, is equal to 1 over 2. Okay, this is just recall back the basic definition or basic concept of getting probability of an event. Okay, so we can continue for PQ. Okay, probability of getting elements of set Q. We have 2, we have 7, we have 3 and we have 5. So 4 elements over total elements, which is 8. So also we get 4 over 8, which is equal to 1 over 2. And then how are we going to find the probability of getting elements that are in P and Q. Okay, as you can see here in the Venn diagram, there's only one element for P and Q. One element that are in P and also in Q, which is 2. So we have one element over total elements, therefore it will be 1 over 8. And how about finding probability of P or Q? That means getting any elements in P or any elements in Q. Okay, so in these examples, you all have to differentiate, okay, the difference in finding probability between and or events. Okay, so P or Q, that means any elements in P, which is 1, 2, 3, and 4, and any elements of Q, which is 1, 2, 3. Okay, so the total elements of P and Q here are 1, 2, 3, 4, 5, 6, 7. So we have 7 over 8. Okay, so again, we just write down the probability of getting P is 1 over 2. Probability of getting R. Okay, here we have 2 elements in R, so 2 over 8, which is 1 over 4. And P and R. As we can see, there is no intersection between P and R, so therefore, here will be 0. P or R. Okay, or that means we are going to calculate all elements in P, which is 4 elements, 8, 6, 4, and 2. And R, we have 2 elements, 5 and 15, so therefore we have 6 over 8, which is 3 over 4. Very good. And PQ, probability of getting Q, as we already got just now, 1 over 2. Probability of getting R is 1 over 4. So Q and R, there's only one element, so that will be 1 over 8. And Q or R, we have 1, 2, 3, 4, 5. So 5 elements on Q or R, so the probability will be 5 over 8. Okay. Okay, so from the example that we have just now, okay, from the table, actually we can make a verified formula that that relates the probability of non-mutually exclusive events and also mutually exclusive events. So in our example, non-mutually exclusive events here, we have P and Q and also Q and R. So what can we say about finding the probability of P or R? Is actually is equal to probability of P plus probability of Q minus probability of P intersect with Q. Right? So from the values here, we can see that probability of P is 1 over 2. Probability of P is 1 over 2. Probability of Q is also 1 over 2. Probability of P intersect with Q, or in other words, is actually probability of P and Q, as you can see in the table, is equal to 1 over 8. So when we calculate this, we will get 7 over 8. And 7 over 8 is actually equal to probability of getting P or Q. Therefore, we satisfied this formula. And we can also see the examples for Q and R. Right? Probability of getting Q is 1 over 2. Probability of getting R is 1 over 4. And probability of getting Q and R, or Q intersect R, is actually 1 over 8. And when we calculate this, we will get exactly the same as probability of getting Q or R, which is 5 over 8. So, our example satisfies the formula in which to find the probability of event Q, P or Q for non-mutually exclusive events. It will be equal to probability of P plus probability of Q minus the intersection, because for non-mutually exclusive, there will be an intersection between the two events. Alright, but how about mutually exclusive events? As we can see here in our example is between P and R. So as we can see that between P and R, the intersection of P and R, okay, is equal to 0. There is no intersection. So if we substitute into the formula here, P intersect R will be equal to 0. And so the formula of finding probability of P or R is just equal to probability of getting P, which is 1 over 2, plus probability of getting Q, which is probability of getting R here, my mistake. So probability of getting R is equal to 1 over 4, and therefore when we calculate this, we will get 3 over 4. So for mutually exclusive events, there will be no minus for the intersection of the two events, because for mutually exclusive event, there is no intersection between the events. And these two formula, which is the first one here for non-mutually exclusive events and the second one for mutually exclusive events, are known as addition rule of probability. Okay, so now we are going to look at the example. The first example here, we have Lina has 10 pieces of card labeled with integers 1 to 10. If 2 pieces of card randomly selected, find the probability that the selected number is a multiple of 2 Okay, the first is multiple of 2 or factors of 6. So in solving probability questions like this, the first thing is that we have to list down the elements of multiple of 2. So multiple of 2, the elements are from the number 1 until 10, we will have 2, 4, 6, 8, and 10. Alright, and for factors of 6, we will have 1, 2, 3, and 6. Okay, so the second step is that we have to determine whether these two events mutually or non-mutually exclusive. These two events is actually, yes, these two events non-mutually exclusive because we have intersection, same element which is 2 and 2, 6 and 6. Okay, so let's say multiple of 2 is our first event, event A, and factors of B is our second event, which is I call as B. So in order to find the probability of getting A or B, as we recalled just now, this is non-mutually exclusive event. That means we have to minus the intersection, so it will be equal to probability of getting A plus probability of getting B minus probability of getting A intersect with B. So probability of getting A, we have 1, 2, 3, 4, 5, 5 over, we have 10 numbers, okay, plus probability of getting B is 4 over 10 numbers, minus the intersection between A and B are 2 elements, we have 2 and 6, so 2 over 10. Therefore, 5 plus 4 is 9, 9 minus 2 is 7. The probability of getting multiple of 2 or factors of 6 is equal to 7 over 10. So that's the answer. Okay, the second examples. Here we have a box contain 5 red balls and 8 green balls. 2 balls are randomly selected from the box. Find the probability that the selected balls are red or green. Okay, so either red or green. So the first thing, we have to determine whether these two events mutually or non-mutually exclusive events. Alright, so obviously these two events are mutually exclusive. Why? Because when we want to choose red balls, it is not affected by the probability of getting green balls. Okay, tak ada kaitan. Nak ambil merah, nak ambil biru, tak ada kaitan, tak ada yang sama. Okay, so these two events are mutually exclusive events. So for mutually exclusive events, we know that we want to find probability of getting red or green is actually equal to probability of getting red plus probability of getting green balls. And to find probability of getting red balls, the number of red balls is 5 over total number of balls, which is 5 plus 8, 13, plus probability of green balls is 8, the number of green balls, over total number of balls, which is 13. And so 5 over 13 plus 8 over 13 is equal to 13 over 13, which is equal to 1. What does it mean? That means, yes, sudah semestinya, confirm, you will get either a red or green balls when you select 2 balls from the box. Okay, satu tu maksudnya kesudahan yang pasti, obviously gonna to happen. Alright, so I think that's the basic concept for mutually exclusive and non-mutually exclusive events, and that's all for this video. Hope you understand the concept and enjoy learning mathematics. Assalamualaikum.